So we define an inner product space. We went over a couple of examples. Now we are moving on to the new vector space, like the vector space of all 2 by 2 matrices. We're going to define a function as follows. This function takes the entries of 2 matrices and multiply them this way. So the first components, the first entries and the first row, plus the multiplication of the second element, the second entries on the first row, and then it multiplies the first entries on the second row, and finally it multiplies the last entries on the second row and then add them all together. The question is this an inner product? This function is an inner product or not? So as you know, we need to check these 4 axioms. The first one is obvious. Obviously, the inner product between A and B is the same as the inner product between B and A, because you can easily switch these around. This guy is equal to B11, A11, B12, A12, B21, A21, and plus B22, A22. This is obvious. Number 2, it says, hey, if I have A and B plus C, is this equal to the inner product of A and B plus the inner product of A and C? Well, this guy on the left says I have A11 multiplied by B11 plus C11. Plus, now I have A12 multiplied by B12 plus C12. Plus A22 multiplied by, let's just write down A21 first, then jump to the last one. B21 plus C21. And finally, A22 multiplied by B22 plus C22. You can write this in expanded form as well. So you have A11, B11 plus A11, C11, A12, B12 plus A12, C12 plus A21, B21 plus A21, C21, and A22, B22, and A22, C22. This is my left-hand side. Now for the right-hand side, you need to find these 2 and add them together. Very good. So this guy is obvious. You have A11, B11 plus A12, B12 plus A21, B21 plus A22, B22. And then plus A11, C11, A11, A12, C12. A21, C21, and finally A22, C22. Are these 2 the same thing? These 2 are the same. A11 and C11, I have them here. 12, B12, A12, C12, A21, B21, and A21, C21. Both of them are here. A22, B22, and finally A22, C22. So the left-hand side is equal to right-hand side. With the same argument, you can check C. Dot product A and B is equal to CA and B. So for example, you have left-hand side and then right-hand side. On the left-hand side, you have C, A11, B11 plus C, A12, B12 plus C, A21, B21 plus C, A22, B22, just distributed over this definition. On the right-hand side, you have C multiplied by the entries of A. So you basically have CAA, and it's multiplied by B11, all right, plus CA12, B12, plus CA21, B21, and plus CA22, B22. They're basically the same. They're equal to each other. You can definitely check the fourth axiom, which is easy to check. The dot product between A and A. This guy is equal to A11 to the second plus B plus, we don't have B anymore, A12 to the second plus A21 to the second plus A22 to the second, which is obviously the sum of all positive values. It is larger than or equal to 0, and it is 0, which obviously, if all elements are 0, Aij is equal to 0. So we just showed that the vector space of all 2 by 2 matrices along with this function forms an inner product space.